Hey everyone, so let's take a look at another problem and we'll be doing it Google style with the help of Google Docs. So this problem states that we need to find subsets, and one of the things that you would see in these problems or in general if a problem is given, uh, it wouldn't be very clearly defined. So you would have to go back and forth with the interviewer to understand it. For now, let's just say that we have something like 1, 2, 3, and the interviewers tells you that we need to find all the subset which is like the power set of this. That would be something like empty array could be one, or just 1, 2, 3. So just taking all the numbers. It could also be 1, 2. We don't need 2, 1, so he would tell you that we are removing duplicates, or maybe you can just ask him, do we want to remove duplicates? So we will not be having duplicates, so which leaves us with, let's say, 1, 3, and also 2, 3. Yeah, and finally 1, 2, and 3. So what we have seen is we get 1, 2, 3, 4, 5, 6, 7, 8 numbers that exist, which is the number if is always 2 to the power of n, like 2 to the power of 3 is what we are getting. So we are getting 8 numbers that exist. Yeah, this is defined for us, and this is simply what a subset would give you if you were to just see what I have. And let's just take another example. If the example like 0, then it would be like empty array and 0. Yeah, so we need to think that how we are going to make this. And I think one of the ways when you talk about it would be like brute force, but this is one of the questions where a brute force might be like too difficult, because maybe two for loops, maybe something called masking, and I'm completely sure that you would not be asked for brute force in these kinds of problems. And also the brute force would be like n2 to the power n. So we need to directly go for the optimization. So directly optimize, and the particular question is like asking us that, hey, what would be the subset of just this one? Maybe this. What would be the subset of this 1 and 2? Maybe this and this. So maybe I can just break problems into smaller problems, and that is called recursion. So this is one of the problems with recursion. And also there is a thing about it, like this is a DFS problem, and I would be just making too many uh, questions, solutions with DFS, so that you just have it in your head that when a problem arises and it is related to depth first search, then what it is. And we would be taking a look at how we can solve the depth first search kind of questions. So yeah, as I've said, this is a problem where you need to first understand. So I will just write here, and this is what you will write when you are talking to a recruiter. And the first step would be think. Always write this, because otherwise you would just start coding. I was just about to code. You just should always first tell him that we are going to think about the problem. And when I think about it, I will just insert and make a drawing here. So new. And when I think about it, if I have elements like 1, 2, and 3, then maybe I need to just check, and I will just put it into something called scribble mode. I think there is one this. Yeah, so maybe a circle would also be helpful here. So shapes, yeah. So we may have 1, 2, and 3 here, and we need to find how we can change this into a number of options. And with recursion, usually there is a way where you are uh, taking a number or excluding a number, and I will just make sure you understand what this means and how we are going to take or exclude a number. So let's just say that this was 1, this was where do I get my scribble? Yeah, let's just say that, okay, this does not work. Let's just close it then. Yeah, so let's just say that the input was 1, 2, and 3, and maybe I can write here better. And I would want to see that if I can have a slate which is like an empty array, and I will just push my elements into this slate, and let's just say I'm making a maybe a iteration which is like a recursive iteration with I, and every time I make a iteration I am going to increment my I by +1, and it could be something that starts with a 0, and I also push the nums.i every time. So this is a thing that I'm always doing, like I'm pushing nums.i to get that what would my result be looked at when my element is like included, and this would make much more sense when I go and dry run the code. And what would my element would look like if I do not include that element and just without having an excluded version, then what would my code would look like? So an excluded and an included. So this is one of the standard problems with DFS plus backtracking, and I think that this at the moment would not be making too much sense here. But what we would gonna do is that we are going to recursively iterate with included and excluded, and we are going to do it again and again and again till we go to the base case, which is like if my I is would be equal to my slate dot length, which is like I have come to a point where my I or my number is equal to this actually nums dot length, which is like the number's length that comes here. So let's just first dive into the code, and we will quickly come back to this so that this makes much more sense. Yeah, let's do that. And I will just go to a new page, and I'm going to write a code like const subsets. And one more thing that we usually do is we switch to consolas is equal to nums, and this is our array that we have to take use of. So we are going to make a variable called result. This is something where we are going to store our result in, and then we are going to make a template called DFS, and this is something that would stay common in all the questions that are regarding DFS. So this would go something like nums I and slate, and this would be initialized with like what's my initialization would be nums, I could be like 0, and slate would be empty. So this is the slate that would get filled up with elements, and this would keep getting filled up with different elements, and this would get pushed into my result, and the result would be pushed once the number is equal to n. And I will just see how this could be like equal to n, but also every time we are making two recursive calls with DFS and getting a 2 of n, which is like 8 results just by making this. And let's just see how. So as I told you, the base case would be, and I believe that this is something you will have to trace with a pen and paper, but also I would be doing that. So then we would be making a result dot push slate, and now I will go back to my recursive case, which is like I would want to get nums I plus 1, like we are incrementing our I, and slate. So this is like I do not include a new element, and I am just making a depth first search here, but then again I do with an inclusion of a new element like nums I. So we are including or excluding an element, which would be giving us different kind of values and excluding elements the way we want. And I will just show you how this makes sense. Nums I plus 1 and slate. Finally, we would be doing something called backtracking, which is like slate dot pop to pop out some of the elements. And yeah, before I go and see this, we do another thing, like we check it with the easiest tool provider like ChatGPT, and we would be asking it, check my code, ignore capital capitalization. Let's just see what it gives as a result. Capitalization is okay. Returning the result. Definitely we would be returning the results, and let's just see, we are doing it right. We have to return it, which is something that we have missed. And other than that, we are including and excluding the numbers, and we are backtracking as well. So this is our base case, where once we have pushed into the result, we can just return, and here we can just make it in different lines so that it looks more clean. Yeah, and we can ignore the semicolons now. Yeah. Another thing that comes here, that once we have called it, we need to return the result. And yeah, this is one of the things that if you forget, then this would be something where the interviewer will have a talk with you. He would be asking you back and forth, like, what if the result is on the base case? Are we missing something here? So he would be actually trying to help you a lot, and this is like a back and forth communication. So the more you talk about it, and the more you say that, yeah, this would be traced, and maybe I can just trace on a pen and paper and then explain better on my approach and how this is working, he would be more and more intrigued, and we would be having a two-way communication the way it should be in interviews, and not like you have solved the question but he is not clear and it feels like you are also not clear. So let's do something called dry run, and we would be just doing it with 1 and 2, keeping it simple. So the very first thing is, we are getting 1 and 2 here. The result would be empty, so I'm just going to write like my result is currently empty, and my slate is currently also empty, right? So 1 and 2 as my nums. My length would be equal to 2 in this case, which I don't have to write, but still I have written nums.length, so we can just refer to that. 2 would be our constant length that always exists, and the result would be empty, and we would be just filling this in, and the I would be increasing with a slate that exists, and that would getting some kind of pop with backtracking. So let's take a look at how this all happens. The very first DFS call would be, and whenever I'm calling it from outside, I'm calling it with nums 0 and empty array, and this is what would be the first input to this. It would just go to the base case and ask that, is my I, which is 0, equal to the length, which is 2? It's not, so it would not go inside. It would be making two function calls here. One would be including the element, other would be excluding the element. So the first function call is like excluding the element, and it is like asking me to make a function call with DFS with nums as 1 and 2, which is like always would stay the same. So I'm just going to write as nums. I is 1, so my I would finally become 1, and my slate as empty because there was nothing pushed into it. So this is the call, and here I am just pushing one element, and I'm also making another call here. So, and this would be I plus 1, so I is 1, but I also have my element that exists, nums I, which is what? 1, because it is nums of 0. This I plus 1 does not increment 1 itself, so this is how we have the nums I that is pushed. So the first element. And now because this is recursive and because this was called first, we would be taking a look at this first. And this is about recursion. Like, think of it like there was another whole function that looks identical to this. Maybe it's called DFS2 that existed, and that was doing its thing. And then we would only come to the next lines of calls. So I have actually written them together, but just go through this first. When this is whole pop with all the returns, all the base cases, then we can only go to the next one. And because this one has nums I and empty, so it will go back with these values. My 1 is not equal to 2, which is like nums.length is 2, so this is not passed in this if case, and it again makes a call to this DFS, and that DFS looks identical to this, so that had its own two functions that existed inside of it. So I'm going to just do it like this right now. Yeah, that I would again be calling something like with my values of DFS nums I plus 1 and slate. which in this case would be, because my initial I is 1, would be 2 here, and then this one, but inside of the this one. And this is, I think somewhere you have to trace it down to understand, yeah, every time inside of function there existed two other functions, and maybe just call them different names, like this is an identical function with a different thing that will return its own thing, then I can come back. So now we will push another element. So, and I think it would get, I think it would start making sense now. So we have nums again, we have I, which is like 2, and we have our element at let's just see, not at 2, because this is I plus 1, and because of this I plus 1 we had called something like an empty array, and the number here was this 2, right? So in the very first case we had I plus 1 as 2 and slate. Now we have DFS I plus 1 as 2 and slate, which is like the first element, because this is the call that is giving us this I plus 1, like 1 plus 1. So it's actually this one, but inside of that. So this would be having the value of the first element, which is 2, like 0 and 1. Yeah. So now these are called inside of this, and both of them can get popped off because both of them have the base case that hits, like both of them have the value 2 and the nums or the length is 2. So we get both of these first, like the first one that would be here, the base case that hits is like empty array. So empty array comes in the result, and we will also have 2 that comes in courtesy of this function inside of that function, that is giving us 2 occurrences on each time. So we have this popped off, it returns as empty, it just reflects to this result. We have this popped off before that one, so that also comes back, and now we are back to this that has gotten all the inputs, and those were like inside of it, and finally this gets popped off, and we did a slate dot push. So we can just simply remove this. We have the first 2 elements that existed courtesy of the function inside functions. We now make a slate dot push, and that would give us this one that exists, and now we would be going through this one, the included versions. So this is actually something that would have the value of 1, and just think that identical functions existed with this value, and they are coming here. So nums is like 1 and 2, it would never change. My I is 1, which is not equal to 2, and my slate has finally having an included value of 1, which I have never seen before here. So it's not in the result at the moment. So it doesn't hit my base case, obviously. It goes through this and this, but those 2 are inside of this. So we again make 2 function calls, 2 calls DFS, and like nums 1, and just the slate in, which means like this, and because this is like I nums plus 1, so here, and we make another call, so okay, yeah, DFS nums I plus 1, and this is I plus 1 2, and this is after the slate has pushed in the ith element, which is like 1. So we are pushing it, the element, and it is giving us 1 and 2. And I think this would make much more sense if you try to trace it down with a pen and paper, and like this. So we have again inside of this, when we call this again has like 2 function calls inside of it, and this one is actually this one call, but it is inside of this that exists. So this is like a DFS2, which is like the same problem, and this DFS2 has called another DFS3 and 4, which looks like the same problem but does its own thing and just comes back. So now we are calling this, and we are calling this, one is excluded, one is included. The very first thing, because it will go in order, it's like a blocking synchronous language. So we are calling this here, it is like nums 2 and 1. Now my 2 is equal to nums dot length, which would give me that my 1 is finally getting pushed, and I'm able to return from that query function. Yeah, and this gets returned. Now time for this function that had 1, and we are able to finally give it 1 and 2. This would be again, the value is 2, so it would again go to our base case, and we are finally able to get 1 and 2 as well, which only happened because we included it once, and that one function actually gave 2 more recursive calls and gave us 1 and 1 and 2. So this is how it is happening. It would go back, yeah, and this would go back, and my value for DFS 1 and 1 has already got both of its cases hit. It will now go to the next line, and it will just pop off the slate element. The slate would become empty, and we would be finally able to have all the calls as completed. We would be able to return back with our I valued at 2, and finally when we have got back from all of the results and we have got these values just because of the recursive calls that we were making, we get back the result of this, this and this, and this is how you would be trying to trace it down, that how every, as I was telling in the starting, how every item that gets pushed gives to give context to like 2 more possibilities every time, and if we have like 2 to the power of the number of elements that are pictured for us. And yeah, that would be all about this question. I would be doing more questions with the same approach, with the same kind of a cons DFS template, and let's take a look at some of the hard problems also based on this DFS approach. And yeah, just see you on the next one. See ya.